Have you ever wondered how submarines, those mammoth machines of the deep, work? You're not alone. These underwater marvels have been a source of human fascination for centuries. From Jules Verne's fictional Nautilus to the real-life nuclear-powered leviathans of today, submarines have captured our imaginations and pushed the boundaries of engineering. Did you know that the first working submarine was actually built in the 17th century? Or that modern submarines can stay submerged for months at a time, carry enough food for a crew of over 100, and travel at speeds of up to 25 knots? But how do these incredible machines actually work? How do they dive, surface, and navigate through the world's oceans? That's exactly what we're here to explore. We're going to break down the complex physics and engineering of submarines into simple, digestible pieces. So, buckle up as we dive deep into the fascinating world of submarines. To understand how submarines work, we first need to grasp some basic physics principles. Let's start with buoyancy. In layman's terms, buoyancy is the tendency of an object to float or sink in a fluid. It's the force that keeps you afloat when you're swimming in a pool. This principle is governed by Archimedes' law, which states that the buoyant force on an object submerged in a fluid is equal to the weight of the fluid displaced by the object. For a submarine to float, it must displace an amount of water that weighs the same as the submarine itself. Next, we have pressure. Imagine you're at the bottom of a swimming pool. You can feel the water pressing against your body from all directions. That's pressure. The deeper you go, the greater the pressure. This is because the weight of the water above increases with depth. Submarines must be built to withstand this immense pressure, which can be many times the atmospheric pressure we experience on land. Density is another key principle. It's the mass of an object divided by its volume. Think of a golf ball and a ping pong ball of the same size. The golf ball is denser because it has more mass packed into the same volume. In the context of submarines, density plays a significant role in the ability to dive and surface. By adjusting its overall density, a submarine can control whether it sinks or floats. Lastly, let's talk about the principle of propulsion. It's the movement created by a force. Picture a boat with a motor at the back. The motor pushes water backwards, and in turn, the water pushes the boat forward. That's propulsion at work. Submarines use a similar principle, but with a lot more sophistication and power. Now that we've grasped these principles, let's move on to the workings of a submarine. Scene script. A submarine is a complex machine, but we can break it down into key components. Let's start with the hull. The hull of a submarine is its backbone. It's a strong cylindrical structure that houses all the operational mechanisms and living quarters. The hull is built to withstand immense pressure that increases with depth, allowing the submarine to descend to great oceanic depths. Next up, we have the ballast tanks. These are the lungs of the submarine. They fill with water to make the submarine heavy, enabling it to dive, and empty out when the submarine needs to surface. The balance of water and air in these tanks is crucial for maintaining a submarine's buoyancy. Now, let's move inside the hull to the engine room. This is the heart of the submarine. It's where the nuclear reactor or diesel engine is located, providing the power needed to propel the submarine through the water. The engine room also powers the electrical systems, from the lights and radar to the life support systems. It's a hive of activity and the beating heart of the vessel. Last but by no means least, we have the control room. This is the brain of the submarine. It's where the captain and crew monitor all the submarine systems, navigate the vessel, and make crucial decisions. The control room is filled with screens, dials, and buttons, all designed to keep the submarine and its crew safe and on course. But these are just the main components. There are numerous other systems and elements, like the periscope that allows viewing above the water surface, torpedoes for defense, and sonar systems for detecting objects underwater. Each plays a vital role in the overall functioning of the submarine. With these parts working in harmony, a submarine can dive into the ocean depths and resurface safely. It's a marvel of human ingenuity, a testament to our ability to adapt and conquer even the most challenging environments. The magic of submarines lies in their ability to dive and surface at will. But how do they do it? This is a question that has fascinated many for decades, and the answer lies in the clever use of a system known as ballast tanks. Ballast tanks are large compartments within the submarine that can be filled with either water or air. They are fundamental to the operation of submarines, controlling their buoyancy and allowing them to dive or surface at the command of the crew. When a submarine needs to dive, the ballast tanks are opened, letting in seawater. This increases the weight of the submarine, making it heavier than the water it displaces. In other words, the submarine's density becomes greater than the water's density, causing it to sink. This is a process known as negative buoyancy. At the same time, the submarine's diving planes, which are essentially flat surfaces on the front and back of the submarine, are angled downwards. This pushes the water over the top of the submarine, helping it to descend deeper into the ocean. Once the desired depth is reached, the ballast tanks are partially emptied by blowing out some of the water with compressed air. This creates a condition known as neutral buoyancy, where the submarine's weight is equal to the weight of the water it displaces. In this state, the submarine can maintain a steady depth and navigate underwater. When the submarine needs to surface, the process is reversed. The ballast tanks are blown completely dry of water, replacing it with air. This makes the submarine lighter than the water it displaces, causing it to rise to the surface. This is a process known as positive buoyancy. Simultaneously, the diving planes are angled upwards, pushing the water under the submarine and lifting it towards the surface. Once the submarine breaches the surface, the ballast tanks are sealed, preventing any more seawater from entering and maintaining the submarine's buoyancy. This intricate dance between water and air, weight and displacement is what allows submarines to navigate the vast and mysterious depths of the ocean. It's a system that's been perfected over a century of naval engineering, and it continues to be an essential part of submarine operation today. So there you have it. The secret to how submarines dive and surface isn't magic at all, but a clever application of physics and engineering. It's a testament to human ingenuity and our relentless quest to explore and understand the world around us. And while the principles might be simple, the execution is a marvel of modern technology. From the powerful pumps that fill and empty the ballast tanks, to the precise controls that adjust the angle of the diving planes, every aspect of a submarine's operation is a testament to our ability to harness the laws of nature. It's a simple yet ingenious system that allows submarines to navigate the ocean depths. Submarines don't just sink and float, they also move forward and navigate in the vast ocean. So, how does a submarine propel itself? It's all about engines and propellers. The engines, typically diesel or nuclear, generate power. This power is then used to turn the propellers, pushing the submarine through the water. The speed is controlled by the rate at which the propellers spin. The faster they spin, the quicker the submarine moves. But moving forward is only part of the journey. How does a submarine know where it's going? Enter sonar and other advanced technologies. Sonar, which stands for sound navigation and ranging, uses sound waves to detect objects and determine distances underwater. This, along with GPS and compass systems, helps the submarine navigate the vast, often murky depths of the ocean. So it's not just about going up and down, it's about moving forward, knowing where you're heading, and successfully reaching your destination. Indeed, submarines are marvels of engineering, conquering the ocean depths with their intricate mechanisms. From Jules Verne's fictional Nautilus to the nuclear-powered submarines of today, these machines have always fascinated us. Our journey today took us through the intricate world of submarines, a marvel of human ingenuity. We started by understanding the basic physics that allows these giants to float and sink, a clever manipulation of buoyancy and density. We then dove into the complex structure of a submarine, appreciating the engineering marvel that it is, designed to withstand the immense pressures of the deep sea. We discovered how submarines dive and surface, a delicate dance of filling and emptying ballast tanks. We navigated through the propulsion and navigation systems, marveling at how these underwater vessels move and find their way in the deep blue. At the heart of it all, it's a blend of physics, engineering, and technology that makes these machines work, a testament to human curiosity and perseverance. So, the next time you see a submarine, you'll know exactly what's happening beneath its steel exterior as it submerges into the mysterious deep.